Okay, so I want to talk about the crossed aldol reaction or mixed aldol. This is where you have two different components coming together in an aldol reaction. And first of all, I want to explain there's a problem in trying to do this under the classical type of conditions. Because if we just take something like ethanol and propanol and try putting them together, we can have ethanol condensing with itself. We can also have the enolate of the ethanol reacting with propanol. We can also have the enolate of the propanol reacting with the ethanol. And we can also have propanol reacting with itself. So we have four possible products here. So how can we make just one of them? Well, if we want to make obviously this one, ethanol plus ethanol, we just not have any propanol in there. But if we want to make one of these crossed products where we have a particular enolate reacting with a particular aldehyde, then what we need to do is try and make the enolate separately and then react it in a separate step. Let's look at some of the ways you can do crossed aldol reactions. For instance, if we have one component that cannot form an enolate, for example, an aryl aldehyde, this aromatic ring has no hydrogen on the position that's attached to the carbonyl, so it can't form an enolate. And so things like benzaldehyde make good substrates for this kind of crossed aldol reaction. Another one is in fact formaldehyde itself, the simplest aldehyde. Although that's a gas at room temperature, you can use aqueous solutions of it and you can use it in other forms. You might also have a tertiary alkyl group attached, like a tert-butyl attached to the aldehyde. So any of those kinds of things will be great partners in this reaction. For example, an experiment that we ran at Brandeis many times is an aldol reaction with acetone plus acetone plus two benzaldehydes. We form an enolate here that attacks and then dehydrates, then it forms an enolate on the other side, attacks the second mole of benzaldehyde, and we end up with and you may remember that as a ligand on palladium, DBA, dibenzylidine acetone, is the traditional name for that compound. So we can do that in that case, but what do we do in the case where we don't have this situation, where we have alpha protons on both partners? That's where we need to use some other tricks in the next part. Okay, we're going to talk about ways of running mixed aldol reactions, and the most general way of doing this type of chemistry is to preform a stoichiometric enolate of one component and then react it with the other component. And that works fine for almost any type of enolate, but not with aldehydes, because you can't easily make stoichiometric enolates from aldehydes, though it can sometimes be done with potassium hydride. But with LDA, that won't work. But for most things, let's see an example, say with LDA on a ketone. We'll form the kinetic enolate at low temperatures, and kinetic enolate, remember, would go on the less substituted position, the more accessible position. And then if we add an aldehyde to that, we get the Aldol product. And this is just a racemic mixture, in fact. That's after acidification and workup. That's it. Okay, we can also do it with ester enolates, and I have an example here. If we take just ethyl acetate, one of the simplest esters we can use for this, and it's LiHMDS, that's the base given in the paper. We'll get the usual kind of enolate, and that will condense with something like cyclohexanone to give us the aldol product. Now, what do we do if we have a situation where we have we want to make the enolate of an aldehyde and then condense that with something else? One of the most popular ways is actually to use a sort of enolate derived from an imine, for example, if we make an imine from cyclohexylamine or cyclohexylamine, we can make an imine like this, and we can deprotonate it to make an enolate. So I have an example of that reaction that's quite nice. This is the typical way that you prepare an imine like this, possibly with acid catalysis. And this is a reaction we learned in Chem 342. But once you have an imine like this, this is derived from one of the very simplest aldehydes, ethanol. We can make a sort of enolate from it with aldehyde. And that will then do a normal Aldol type reaction like this, and give us our imine reforms, and we get after work up, we'll get the alcohol here. And in fact, we probably won't see this form because probably in the workup we will get the ketone forming, because these imines, remember, are pretty easily hydrolyzed back to the aldehyde. This would just be very mild acid. You don't want to dehydrate this or anything like that. And there's the product. Now it's important to notice that we cannot cheat and just do that, because we would not form the enolate. This would just polymerize and do all sorts of nasty things, so that fails. So although this seems like it's going around the houses, in terms of an actual lab procedure, it's not that much longer, and you could probably still get through this whole sequence in an afternoon, so it's not too bad an alternative.